All right, guys, so we're back and we're recording. Now, what I said was I was going to give you a fun example. Yeah, it's kind of a fun example, right? So I don't know how many of you guys exercise, go to the gym, stuff like that. So I kind of compiled this list. We choose it. Zeta, Celine, what we do, and please let me know if I need to call you by a specific name, some of you in here go by your middle name. What happens is we identify the candidate keys. Okay, thank you, Celine. We identify the candidate keys. Oftentimes there will be only one, like staff number. If we saw a staff table, it's pretty simple, like it's a staff number. If I saw a table with your information here at the university, your student ID would be the primary key. That's fairly straightforward. The thing is, though, is like in the example of your student ID, what we've talked about is that the existing data for you, the existing data for any student, when they come to the university, there's no student ID when you come to the university. Right. Well, the information that we have for you, your name, your surname, your birth date, if you get into it, your father's name, your mother's name, all of that stuff, most likely uniquely identifies you. All right. For a lot of you, uniquely identifies you. But we cannot be guaranteed that it will. We cannot be guaranteed that someone with your name, your last name, born on your birth date, with your father's name and your mother's name, as much as that sounds like, well, yeah, that should uniquely identify me, there's a reason why that we cannot guarantee with certainty that would uniquely identify you in our system. And so because we cannot guarantee that, we give an extra column, the student ID in this case, to be the primary key. Okay? But in general, so here's what we do. We take the existing information, we identify all of our dependencies, all of our functional dependencies, not worried about full or partial or transitive, not dealing with that. We're identifying the functional dependencies, okay? And once we get to a place where we have some set of columns that uniquely identifies all the other columns in our table, once we have that, and as long as no subset identifies all the other columns in the table, that becomes a candidate key. We likely, in some situations, can get more than one candidate key. Once we see which ones there are, we choose one. We choose one. There's no right or wrong way to choose it. Usually, if one column is a candidate key, it makes sense to make that the primary key. If no one column is a candidate key, but you have one set of columns, like 2 columns makes a candidate key, but another candidate key is 4 columns, it makes sense to do the 2-column version. Okay, that's usually how it works. Okay, well, okay, you got right on it, Kershaw. Good job. Let's see. B, he says B and E determines everything else. What day, what exercise I'm doing determines everything else. Let's see. I'm tempted to say you're right on that, but oh, wait, no, not quite. There is one little problem. Right, so Arjun, let me just tell you, this is based on you're doing the same exercise, multiple repetitions. So for example, let me just give a little explanation here. When it says complete, it means that this person did whatever, 2 or 3. So people do different amounts, but they did all the repetitions. Right, so you wouldn't necessarily, like, say, for example, here, let's go with this example here, the press. A shoulder press, right? Or a leg press. I'm not going to display that one on the camera. A shoulder press, You would do it once, then you would rest, and then you would do it again. All right. And some people would do 2 repetitions. Some people do 3 repetitions. You don't want. I don't think you do more than 3 usually. But then, as Kershaw said, in a typical day, you wouldn't do it more than once. Right. You would do those repetitions. You would not come back later in the day and do the same exercise again, because those muscles, they need to relax. They need to rest to rebuild. Okay. Interesting, if you didn't know this already, the way that you increase muscles is actually these exercises tear your muscles, and then when your muscles heal, they heal back and build and get stronger and bigger. So if you didn't know that before, that's kind of an interesting, that actually what you're doing is actually intentionally injuring your body. You're intentionally tearing your muscle so that it can grow. Okay. But looks like I named a shoulder press and a leg press. So you're close with the BE, I would say, but the problem is you have 2 threes to that, but these other values are not the same. Yep, okay, I can see that. Yep, if you take the day and the region and the type of exercise, I think you are on to something there. That shouldn't have been any, that should have been 0. I changed it. All right. Yep, I think you're right. I think what you've just done is probably identified our best option for candidate key, except there's one. Yeah, we'll just stick with it. So, by the way, this could be an example of where a single cell has more than one value, right? So this column is saying how many repetitions on the last time I did it. So last time someone did it. So 11 would be partially complete. So I didn't do all the repetitions that I was supposed to do on the last set. All right. So this right here could be a different way to look at it, because what this is a pull-ups, and if you know what pull-ups are, you pull them up, right? You pull your body up, and the way this exercise would work is instead of having a specific set of repetitions, you just do it until you can't pull yourself up anymore. And you basically record how many that was. So one time I did 9, and the next time I did 5, and then I was done. All right. So this could represent a cell with 2 values, one being 9 and one being 5. All right. So the way we could do that then is, so the way that we make this happen, we copy this data into here. Make this 9, this 5, right? And then the same thing with these 2 here. Now we'll do it this way. So this is 8, 6, this is 13, and 9. I think that's all of them. Okay, yep. All right. All right, so now we have a slightly problematic issue, right? Where what if these 2 values are different? Okay, maybe this was a little bit more complex than I realized it was on the very initial. So what we'll do is I want to make this easy. So we're just gonna delete this. Okay, we're just gonna remove that. Okay. All right. We'll just record whether or not we've completed it or not. Okay. So back to our thing is A, B, E, and C. So we could say the combination of B, C, and E A, D, F, G, H, I, and J. Okay. All right. Are there any other dependencies that we can identify here? So specifically, any partial dependencies? Yeah, I agree. That's why I took it out. That's why I took that last thing. Yeah. That was what I was trying to say was an example of how multiple columns could be done. A cell could contain more than one value, and it ended up not working out like I wanted it to, so that's why I took it away. All right. Let me do this because I don't want region to have any blanks. Are there any other partial dependencies that we can identify, or transitive dependencies? Yeah, C determines A, doesn't it? Right? C determines A. C tells me what type of thing it is, right? Good. And so that would be a partial dependency. Somebody says F determines G. You're right. Sort of. See, null becomes 50, but null also becomes 16. So it's not quite a one-to-one. This would be an example of what we would call derived data, right? That the amount of pounds is determined by the number of kilograms, right? Because kilograms to pounds is like a 2.2 conversion rate. So it's not so much that this column determines this column, so much as the value here can determine that, but obviously in some situations, these are nulls, right? Okay, let's see what else. Are there any others? Does B determine anything? Does C determine anything? E determines C. Let's see. Oh wait, I duplicated these. Oh, I see what I did. I duplicated this, so I need to undo that. Thanks for that. I see now what you were saying there. This one here needs to go too. Okay, so you said E determines C. Okay, the only problem with that is this right here, right? Press could be shoulders, press could be legs. And I think it also could be chest. Yeah, press could also be chest. So now E does determine A. We could say that. Yeah, we could say E determines A. See, I did something wrong. I see what I did here. If it weren't for this cardio stuff, if I only had my weightlifting stuff, then we could say C determines B, couldn't we? Ah, but I added that cardio stuff. B, D, and C determine A. B, D, B, C, D. Yes, cardio. Atsukan, you're right. You're right. Absolutely. It absolutely matters. But what I would probably do to make my C determines B for the example part here is maybe just remove that, but we'll just stick with it for now. It's fine. I'm trying to find a transitive dependency. A and D, nope. E is part of the primary key. Man, I cannot find a transitive dependency in there. Other than that, well, you didn't bring up the F to G. The problem is that since this is null, it can't really be the determinant. E determines a lot of stuff, doesn't it? Because E determines, or sorry, the E and C combination determines a lot, doesn't it? Because E and C together determines A, determines it doesn't determine B, actually. E and C together determines G, doesn't determine H, actually. Oh, so we have an H involved here. B, C. Yeah, determines H. B, E determines H, right? B and E, which day of which exercise determines the instructions, right? Could, well, again, that press, that, man, I messed you guys up with that press, didn't I? Try to make this fancier than it had to be. I'm deciding whether or not to change that press to make things easier on us. All right. I don't often suggest you do this, but let's change our data, make things easier on us. Let's get rid of this duplicate press thing. Okay, which means we end up in a situation where we have okay. I think that's everything. So now we still have a problem where your original claim, which now looks really good for this. Yep, nope, yeah. Now we can have B and E together determine everything else. Sorry, this is what happens when you don't name your stuff well. All right. All right. We still can stick though with the other stuff where C determines A. All right. What I really wanted was for C to determine B, but that doesn't, so it's not wrong. C still determines A, yep. E still determines A, yep. E determines C also, right? E determines C, right? Okay. All right, so let's go with this for now, because we're going to see how to take this and make our other tables, okay? Because what we're going to do is we're going to say, okay, this is our primary key, right? Anything that determines all the others. Now, that's not the only, it's not the only candidate key that could exist. We could also say the combination of let's see. I'm not seeing another one right off the top of my head, but if there was another one, that would be fine too. So, but what we say is this is our primary key. So the way I would do this is I would then change the format on that, and maybe even the columns too. To indicate that this is my primary key. Oh, that's bright. Oh, that's bright. A little less bright. Okay, to indicate that this is my primary key. So now, what the first thing that we need to do is we need to say, okay, what are some partial dependencies that exist? So anything where B alone determines something else, anything where E alone determines something else. Is there anything where B determines something on its own? Not really, is there? Because 0 does not determine A, 0 does not determine C, right? 0 does not determine order, 0 does not determine exercise, 0 does not determine this stuff, right? 0 does not determine this, although here it does, but here it does not. 0 does not determine this, 0 does not determine this. Okay, so B alone doesn't determine anything, but do we have a column or set of columns that E determines? And what is it? Actually, let me do this real quick. So this would be UNF. This would actually be first normal form because it has a primary key defined. All right. So is that it? A and C. Does E determine? E determines A. Does it determine B? No. Does it determine D? It could, couldn't it? It does determine B, doesn't it? I'm sorry, D. Which exercise is which order in the order of how we do it? But is there an example where the same value of E gives a different value of D? Well, every time I have outdoor bicycle, D is null. Every time I have run, D is null, right? So every value of E results in the same value of D. Right? Every exercise has the same. This exercise value has the same order. So stationary bike, so run. Every time I see run, order is null. Every time I see outdoor bicycle, it's null. All right. So null can be the determined value. It cannot be the determinant. It cannot be on the left side. It can be on the right side. I think it works. It works. Okay. What about any others? E determines E, of course it does. Does E determine F? Every time I have a value here, yep, current chest press is 53. And same thing with this, right? So F and G. What about the instructions? Stationary bike, 15 minutes, run 3 kilometers, run 5. Oh, nope, that doesn't work. This value has 2 more separate possible values over here, right? So no, it doesn't determine H. Does it determine I? Does E determine I? No. E does not determine I. Now, one thing I will say is that the combination of E and H determine I, right? The exercise with the specific distance determines when I did it. But it would also be the combination of E and B determines I too. And the combination of E and B determines H. Interesting. But that's this over here. Okay. Finally, does E, according to J, we determine the next instructions for J. Right. Yeah. I mean, we could. This is not a historical list. Do we define that? Yeah, I mean, I guess it could also be defined based on future as well, because again, this is about the holding for all time. So I'm going to add, I think I got a lot of exercises already here. I may not add any more for myself to do, because basically, like, let's say run 8 kilometers, did that on the 5th. Let's say I do it today. Again, all that's going to happen is this will get changed to today's date. Okay, so it's still the same. So it's not that I add a new row for that same exercise. All right. Does E on its own determine J? And the answer is no. Because some of these are complete, some of these are not. All right. All right. So I think we're good. I think we're good with right here. So now we have, let me delete this there. So now we have a partial dependency, right? Where B and E combination determine these, all of them. E determines some of those as well. Okay, so the way that we would do this, let me copy over our dependencies too so we can see them. Actually, I need to move it into second normal form. So we're going to take our first normal form table, over. Okay. Now to get to second normal form, it means that we want to get rid of all partial dependencies. So anything where E was the determinant for something else, we're going to take a copy of E, move it into its own table, and then we're going to take a copy of all of the columns that E alone determines. So we're going to take A, C, D, F, and G. We're going to move them over here. All right. And then we can delete them from this. A was B included in that? I can't remember. A, C, D. Go from the back. These. Okay, so this one, these two, and these two. Okay. Now you might think, wait a second, why are you getting rid of all this data? All of this data is still there, it's just over here now. Right? So now, in order to find out what the information for stationary bicycle, what type of exercise is stationary bicycle, I don't have to look in this table anymore. I look over here to this table to see that it's a cardio exercise. And then what we can do here in a much better data example, where are you? Right. We basically now get rid of duplicates because since this is our primary key for this table, we don't want duplicates in here anymore. Oh, we had an extension. We had a duplicate extension. I was supposed to get rid of that. All right. So let's look. So see this duplicate here, this duplicate here, this duplicate here. Notice all of that's the same, right? So what we can do is one more. Right. So now the outdoor bicycle, even though it shows up multiple times over here, it's always going to have the same type, region, order, pounds, and kilograms, right? Because I don't lift weights while I ride my bike. All right. Same thing with these here. All right, so we can delete those. So now this is now second normal form because all cells here, all cells here are determined by the primary key and no subset. And the same is true for this table here. Now we would give these two tables names. So like this name would be exercise day, something like that. This would be exercise. That's just so hard. Info maybe. Okay. All right. So now we have had this, and let me do this. Let me label these what they were originally. So type was A, because we're going to need to maintain that information. Region C. Pound F and G. Exercise was E, right? Yep. Day was B. B. Instructions, HIJ. That was the original column letters. Right. I like to use column letters so it's easier for you guys to write it down what the functional dependencies are. Okay. All right. So if we go back to our original functional dependencies we identified, right? Now we see that B and E determine HIJ. No partial dependencies there. E determines A, C, D, F, G, right? No partial dependencies there. Great. All right. What about transitive dependencies? Are there any situations where this value here determines this value here. And it can be a combination too. So like the combination of this and this determine this. The combination of this and this determine this. On either side of this. We did have this one here, right? The region determined the type, right? Abs was weightlifting, biceps was weightlifting, legs is weightlifting, cardio is cardio, right? So what we would do there, C determines A. It's just like before. I'll move it over to here. Let me copy this. Third normal form. Okay, so we're going to take these two, bring them over here. Okay, we move this to the side since the thing on the left is going to be our primary key of this thing here, right? So now we'll call this type table, or maybe the exercise type table. Just like before, I want to make a filter with this. This should also be my primary key. So now notice now we have a lot more duplicates we can delete now, right? And finally tricep here. All right, and we don't need this here anymore, right? We delete this column from there because now in order to find out the type weightlifting, we go through here to there. All right. Was there any other? I didn't see any other. I mean, I guess the combination of C and D would tell me F and G, right? Possibly. Does that work every time? Let's take a look and find out. The combination of C, actually, let me what is this first? So there are any times where this, oh, nope, we have an issue. Yep. Other than that back issue, we have that issue. This would have worked. Chest too. Okay, so there are a few examples where that doesn't work. Okay. So this would be our set of tables in a third normal form database. This data set turned out more confusing than I intended. So what I'll do is for our example next week, I'll default back to a simpler example. That way it can be a little bit clearer what's going on here. But the main thing I wanted you guys to see is how we can take that column, right, that set of columns from here, and remove those duplicates so that now, in order to determine if I said, okay, the elliptical machine on day 0, right, I wanted to see the information of what that means, right? So the elliptical on day 0, I do it for 15 minutes. What type of exercise is that? Or let's see, what region am I doing for that? That's cardio. And what type of exercise is that? It's also cardio, right? Because this points back up to cardio here. Right? Or if I were to say, yeah, if I were to say to my friend, yeah, I'm gonna do a chest press, or I'm gonna do a pull-up. I'm gonna do a pull-up today, right? Well, I can say I did it last on the 11th of April, and what body region does that affect? Like, what body region is the pull-up? Well, let me look at the exercise info over here. The pull-up is my biceps. Okay, it's my biceps. And what should be the weight? 45. Okay, and then biceps. Oh, what type of exercise is that? Is that cardio? No, my biceps are as a weightlifting type of exercise, right? So again, one of the things I want to point out here is you'll see with each of these the confusion that this causes us in trying to figure out all that information, right? For us humans, this is a lot clearer, right? If I wanted to know about the pull-up, I would simply say, okay, where is it clear? I would say, show me pull-up. Now I've got all that information staring me right in the face, all in one place, all easy for me to figure out, right? But for the computer, for the database to maintain this information is a lot harder. Because say, for example, I wanted to change my abs. Instead of doing abs on day 0, I want to do them on day 1 from now on. Well, in the third normal form, I guess that's actually, where am I? Where abs? I guess. I still would have to do with all these, wouldn't I? The different exercise would be there. Let me find an example where something that changes. Okay, let's say I wanted to change the type of exercise that oh, I got it. Oh, I see a problem. I typed weightlifting wrong. So let's say I wanted to change it here, right? I'm going to change it here, but I didn't change it for all the others, right? This makes data inconsistency, right? Here, that same problem could happen, but at least it affects more, right? It affects all of these all these ab exercises, right? Cannot believe I did that. All right. So what happens is that data consistency can be maintained a lot better. Yeah. Let me do this. I said I would come up with a better example. There's actually a better example from last year. I didn't want to reuse the same example from last year, but I might just have to. And that's what we'll do on Wednesday. So I really apologize if this was more confusing than it needed to be. So we will do a different example on Wednesday to make sure that you guys have a better understanding of how this is supposed to work. All right. Maybe this can also show you that be aware of how you get your data for your group project. All right. That it could be a little bit difficult figuring out where all the functional dependencies are. Yes, you need to do this for a table with 30 columns at least, right? And this one that we just did had J10. I'm sorry, Kershad, I'm sorry. But the truth is, I'll tell you this. This isn't the same data from mine, but I have a spreadsheet that I use for my own exercise regimen, for my own exercises that I do. Clearly, what I've learned is I am storing this in a very weird way. All right, so in a very difficult way that if I wanted to convert this, which I have thought about in the past of converting this into a database, clearly I have not started off well in storing this in an appropriate way that makes this easy for a database. But I promise you, when we look at next week's other example, you're going to see that it's not as difficult as it seems. Okay. In fact, what I'm going to do is as soon as I get off this call in 1 minute is I am going to share the example from last semester, the UNF from last semester, and maybe you can guys start taking a look at it. It's a lot easier than this monstrosity I just shared with you guys. So, all right, so I'll share that in a couple minutes, and then you guys can take a look at that there. Okay. Promise this is not as hard as it looks. Previous semesters have gone a lot better. All right. Let's take it from there, unless anybody has any questions. All right. Have a good afternoon. Have a good weekend, and I'll see you guys on Wednesday.